Third problem is that science has got a habit of using these kinds of words. Okay, in that sense, they are called logical connectives. Okay? And you might ask, well, and people who produce textbooks hate them. Okay? They hate them because their function is to connect sentences together to say causal relationships, okay, and then up the reading age of the text. So what they tend to do, okay, is they tend to get you to rewrite the text, if you're a textbook writer, to take them out and just have short staccato-like sentences, okay, leaving the poor reader, okay, to actually stick them back in, okay, if they're going to make any sense of the text. Now here's an example, again pulled from the internet, explaining why the sky is blue. And you can see this text has used those logical connectives. They're picked out in yellow because, okay, the sunlight sky appears blue because air scatters short wavelength. Okay, it's a causal relationship expressed in the text. And carries on. Since blue light is at the short wavelength, okay, it's connecting ideas. Okay? And again, another one halfway through. Near sunrise and sunset, most of the light we see comes in nearly tangent to the Earth's surface. So, okay, because of this, this happens. Okay? Okay? These things are inherently part of scientific text. And you excise them, I think, or the textbook writers excise them and deny, I think, I'd argue, access to the real meaning of the text and the causal relationships that are embedded in there. And if the textbook exercises them, you as the science teacher have to put them back in, I'm afraid to say. Here's the fourth problem with scientific text, what the linguists call lexical density. Now, in common English, you get a lot of sentences like this. We never did anything very much about science in our school. I'm sure that's not true of your school. Okay? In that sense, okay? My mother was madly in love with my father. The blue terms in blues are what are called lexical terms. They refer to constructs or concepts. You have to know those constructs or concepts to make sense of the sentence. Fine, nothing particularly wrong with that. Okay? But what's the problem when you come to scientific English? The problem with scientific English is you get lots more of them. Okay? There's obviously I'm picking my examples as well, but you go and look at any of your scientific textbooks, okay? On average in common English there are 2 or 3. In scientific English there can be 7 or 8 in a sentence. Okay? And what does it do? It makes it much harder to read because you've got to know the meaning of each of those individual terms and then you've got to put the lot together. It's a struggle. And it's another reason why reading with students, okay, from time to time, looking at the words, exploring their meaning, is quite important as an activity. Now, all of these, I think, point to the fact that actually what I'm is that we are bedeviled, I think, in our culture. No, I don't think so much, but particularly those people who are teachers of anybody here who's a language teacher doesn't, I think, takes this particular point of view. But there is very much a kind of a perpetration of notion of what I call the simple view of reading. And the simple view of reading says, if you know the meaning of terms, you should be able to decode the meaning of the text. Let us put this to the test. Okay? Here is something I'm going to ask you to read. Okay? So just take a moment to read that. Hopefully it's large enough. Can you read it at the back? Okay, I'll read it out. Okay, so that you can see it. We assume that the atomic energy levels were infinitely sharp, whereas we know from experiment that the observed emission and absorption lines have a finite width. This is from a piece on quantum damping, by the way. There are many interactions which may broaden an atomic line, but the most fundamental one is the reaction of the radiation field on the atom. That is, when an atom decays spontaneously from an excited state radiatively, it emits a quantum of energy into the radiation field. This radiation may be reabsorbed by the atom. The reaction of the field on the atom gives the atom a line width and causes the original level to be shifted. This is the source of the natural line width and the Lamb shift. It's a fairly sort of standard piece of text that you might get. Here's my first question. Okay? According to the passage, observed emission lines are A, infinitely sharp, B, of different widths, C, of finite width, D, the same width as the absorption line. Okay, just take a moment and decide, can you answer that question? Okay, can we have a hands up activity? How many people think they can answer that question successfully? Hands up, okay, if you can. Okay, okay. Okay, a few of you anyway. Okay, normally you do better than that, so I think it might be the small text. Okay, let me try the next one. Okay, same text. Okay, okay. Can you answer this one? It can be inferred that when an atom decays, it may return only to a state more excited than the original one, not return to its original excited state, return to its original excited state, or return to a state less excited than the original one. Okay? Again, okay, give you a little while. Can you work out which one of those is the correct answer?
The options are not very clear.
Sorry, yeah, okay. I'm sorry about that. Okay. I'll read them again. Okay, the first one, 2A, return only to a state more excited than the original one. Not return to its original excited state, that's B. Return to its original excited state. And D, return to a state less excited than the original one. Let's see with this one. How many people think they can pick an answer, they can work out the answer to that question? Okay, hands up. Okay, just a hands up. Okay, don't have even attempt to do your hands up answer. Okay.
Can you repeat the options?
Well, I wouldn't worry about it too much because I think the exercise. I'm not succeeding with this exercise, I have to admit. Okay. And then normally, if I give it to you as a piece of paper, okay, where you can read it, I think it's too small. You can. Most people can succeed with these exercises. They can work out what is the correct answer. What they can't do, okay, and this is really is answer the third question, is do you have the faintest clue what this passage is about? Okay. Okay. And how many anybody here brave enough to say they do have this? They do understand what this passage is about? Okay. Okay. And the point with exercises like this, and I think I really should have given it to you as a piece of paper, is you can decode the words of meaning of individual words. You can infer the meaning. You can answer those questions. But you cannot understand what the text is about. You can't understand what the text is about because you don't have the appropriate background knowledge to bring to interpret what it's saying. What are these concepts like radiatively, line width, okay? What are all of these things that are needed? And the simple view of reading, okay, is what gets us into trouble. Okay? There is much more to reading than just decoding words on slides.